Nintendo Switch, board only. Let me show you what's going on. We have ourselves another smashed up port. The big question will be, is that all it is? The only way we can figure that out is to remove the port and test from there. For your orientation purposes, we'll be working in this area on side A, and when we flip it over to side B, we'll be working here. We're over here and ready to remove our port, but in order to remove the port, I must set up my equipment. And while I set up my equipment, let me throw up my expected temperatures for this job. These temperatures are brought to you by the associate links in the description. If you go to my video description and click on one of these links and buy any of this equipment, a small portion of that purchase will go to supporting the channel. And I greatly appreciate you. It won't cost you an extra dime. Grab our low melt tin. Put some on the iron. We'll just feed it into the anchors. Rub it in real good, make sure it climbs up the leg and goes all the way through. I use low melt here because I know I'm going to clean up the manufacturer solder. If you're just going to hot swap, don't use low melt. Bring the sauce pre-warming around the port, waiting for those anchors to wet, which will happen pretty quickly. And then we'll start concentrating in on the pins, which you can now see from this side. But once they wet, it'll just fall right off. Nice clean pull. While we're still warm and we're over here, we might as well just hit these anchor points real quick. No reason to let the board cool down before we do that. Very good. Easy peasy. Try to remember to clean as we go. I've already gotten a little bit of crustiness going on here. Break it up. As we're already on side A, let's go ahead and test Pi 3 USB. Find ourselves a ground. Okay. And the first thing we're going to test is this big capacitor right here, and the line we're concerned about is the line going to the chip. That's the signal line. And we don't want to short there, and we don't have one. That's excellent. I'm going to find ourselves a ground again, and we're going to test our filters. Make sure none of them are shorted to ground. Typically will not be if you don't have the port on. With a bunch of shorts, but we do want continuity going through the filters. And we do not want continuity going side to side. Okay, everything looks pretty good in this area. Doesn't mean it is, but so far, so good. Now we switch to side B, and we're going to start over here on the M92T36. Again, testing the capacitors around the chip, and the lines we're concerned about are the lines going to the chip. Occasionally, you'll have a capacitor with two lines going to the chip. In that case, only one side of that capacitor should be ground. Let's find ourselves a ground. All right. Continue to test. Ooh. Uh-oh. Looks like we have a short right here on this capacitor. We should not have a short there. And we have a short on this capacitor right here. We should not have a short there. This capacitor has two lines, so only one side should be ground. Alright, and everything else looks good. So it looks like we also have a M92T36 issue. Let's move up the board. We'll check our MOSFET area. Make sure everything is checking out here. It is. Let's check our little filter. Seems good. Let's check our invincible fuse. Still being invincible. So nice of them to make the power management chip the fuse for the system. Let's check our test pads. None of these test pads should have a pathway to ground. And that one does, and we can already tell you that's M92T36. Alrighty, it appears we must deal with this M92T36 issue as well, which these days can be a lot of fun because you can hardly ever get working chips. If I sound non-optimistic, it's because the first 3 chips I have pulled out of this lot have all been bad. I had to use a used chip on the last job to get it back up and running. Not excited. Unfortunately, we'll have to test it once we have the new port on, because we cannot test it currently. All we can do is relieve the short and hope. Don't you want to get into repair? So much fun. We just wait until every pin is wet before we even attempt to pull this thing. Go ahead and plop our other one on while our board's still warm. We'll check our shorts afterwards. Just want to make sure it grabs with the solder before you let go. It doesn't have to be perfect when you put it on there. And press down gently. Just make sure it's flat to the board. And we'll check our work. And we're just looking for good alignment and making sure it's flat to the board. Yeah, perfect. Good. It's all the involuntary practice. Check and make sure we've not acquired any new shorts. We'll run through the testing again. Alright, our shorts have been relieved. And we've not acquired any new ones. Let's go ahead and check our test pads. Just to be sure. We're not making any assumptions here. I don't think we ran around the BQ either. I neglected to do that. But so same deal. Just looking for the lines going to the chip. It has multiple capacitors with 2 lines going to the chip, so just know which side to test. And everything looks good there. And all the test pads look good. Let me be clear. By good, I mean not shorted. I'm a little suspicious about this entire lot I've gotten. Let's gently clean off our pads. We're just gliding over them. We're not pushing down. We're not scrubbing. It is not necessary to put any pressure on the wick other than what's necessary to hold it to the board. It's the flux from the wick that's gumming up the works here. It's not the flux I usually use. Switching to my Pico pencil, I'm going to put a ball of solder on there. I'm going to try and glide that solder over the pads. I'm not really trying to make contact with the iron. You will incidentally do so on occasion. But you're just kind of really trying to run that ball over it. Sometimes unsuccessfully in areas where you don't want to be unsuccessful. Come on. Give me solder where I need solder, man. There we go. Do this solder here. Very pretty. Pico pencil again. More solder. And we'll just try and paint our pins here. As gracefully or ingracefully as our flux will allow. It's my fault, really. I'm just trying to squeeze out the last dregs of this. Very good. Some fresh flux on. As fresh as the end of this bottle is. Okay, place our ports. Flow our port into place. For this, we'll be using rapid air movement. And what we're doing here is just bringing up the temperature of the board enough to flow that solder. We're not holding the airflow in any one place long enough to burn anything, ideally. It does take a little bit of patience. So we're just watching for those solder pads to wet. And we'll press her down into place. Concentrate a little bit in on those hidden ones. Make sure we're getting them. And then we'll release while holding the port down. And once we see evidence that everything has dried, we will release. Okay, that feels pretty good. Doesn't feel like it's loose. If you don't get that inner row, it will kind of feel a little bit floppy. So, but it feels solid to me. I'm going to go ahead and hit these while we're here. You can't touch up the inner row, but you can touch up the outer row. Not really certain why I'm finding this necessary now, but probably because I just don't get to do them that much. I usually get them after somebody ripped the port off. And after they've ripped the port off, it doesn't usually look that sexy. I decided that anything your $200+ hot air station can do, my $80 heat gun can do. So I decided to remove my port. That's usually the jobs I get. Let's get it started here. There we go. Now getting it started is the pain. I'm doing pretty good for having several hours of dental surgery today. I say that now. That's beautiful feed through. Looks like I accidentally got that cap though. Wow, flourishes with my soldering iron probably. Give it a good tap. Tappity tap. Smooth it out. Give it a good clean. Okay, moment of truth. Click on our PSU. We'll activate using the OEM. You must use the OEM on the modified iPhone Power Squid. It does not activate with just 5 volts. And here's hoping. Okay, that looks relatively normal. We're not sticking. Did we actually get a good chip? Okay, I'm going to try the other side. Make sure it's activating on both sides. Test our port. Okay, it's activating on both sides. That is good news. And it looks like it's booting. Very good. Okay, we'll reactivate. Prompt to boot. Plug in our dock. Wait till it gets to good current here, and we'll plug in our dock. Show me a picture. There we go. We are docking. Excellent. If anything was really wrong with the port, we would not be docking. So far, very good news. I'm going to put it in the housing, and I just want to make sure it's charging normally and all that stuff. So we'll do that and go from there. We got a good chip out of the lot, it appears. I hope you're getting value out of this video. Just a reminder, if you find you're not ready to tackle this, I do offer these services, both locally and mail-in. Just head over to micromage.repair, click free quote, fill out the form, and I'll get back to you personally. If you mention this video, I'll give you 10% off on your repair. Okay, I have it in my donor housing, and we're just testing charging, make sure we're pulling the right current, right voltage. Everything's looking good at this moment. We're getting right battery percentage, same as boot up. So far so good. I'm not having any of those weird charging problems that we were having before. I did buy a new donor battery because I think other one kind of bit the dust on our last test as well. So we'll let it charge for a little while and go from there. All right, it's been a little bit, and I'm reasonably happy that everything is working as expected. So I'm going to call it there, take it out of my donor housing, and send it back. If you got value out of this video, I think you'll get value out of this one here. And I'll see you there. Until then, have a blessed day.